Hi again, here another video on mathematical induction, and in this one we will prove that n squared is greater than 7n plus 1 for all n bigger equal 8. So we're not starting at 0 or 1, we're starting at 8. Now the first step in the induction is always to show the first case. So let n be 8. And we will say 8 squared is bigger than 7 times 8 plus 1. Or in other words, 64 is bigger than 56 plus 1, 57. So, yep, we've shown that that is indeed true. So the first statement is true. For the second statement, we are going to look at n equals k. And we say, assume that k squared is bigger than 7k plus 1. Assume this to be true. Now we're going to use that statement in the second step, where we look at k plus 1. When n is k plus 1, we say k plus 1 squared, which is expanded k squared plus 2k plus 1, is bigger than 7k plus 1 plus 1. Okay, now why did I expand this bit here? Well, it is important because we are now going to use the previous statement. And we are going to replace the k squared by 7k plus 1, knowing that k squared is bigger than 7k plus 1, or assuming that k squared is bigger than 7k plus 1. So we're going to use that fact and say, okay, therefore 7k plus 1 plus 2k plus 1 is bigger than 7k plus 1 plus 1. So how do we do that? Well, I'm going to rewrite the left-hand side to reflect the right-hand side. So I'm going to just write 7 times k plus 1 here. Now that gives me 7k, okay, 7k, where I really have 9k altogether. So I'm going to add another 2k. It also gives me a 7, where in fact I only have 1 and 1 is 2. Okay, so I need to take away 5. And I need to prove that this is bigger than 7k plus 1 plus 1. So now I just need to show that 2k plus 2k take 5, is bigger than 1. Or in other words, 2k take 6 is bigger than 0. Well, since n is going to be bigger than 8 or equal, I only here have to show this for k is 8. And 16 take 6 is indeed bigger than 0. So that's true. And for all the k's bigger than that, the statement is true. So assuming that k squared is bigger than 7k plus 1, and I use that 7k plus 1 inside my k squared here, then k plus 1 squared is indeed bigger than 7 times k plus 1 plus 1. I've now shown that. So I've done all the steps required. And now I can say that since P8 is true and Pk plus 1 is true whenever Pk is true, Pn is true for n bigger equal 8, because that's where we started at 8. So there's another induction. The trick always with induction, I think you will agree, is that you have to use that assumption in some creative way for your k plus 1 statement. That is the tricky bit. Sometimes you need sequence and series to do it, sometimes you just need to substitute something like we did here. But yeah, that's the creative part of mathematical induction. Okay, see ya.